me and my dad had this thing where during dinner we like to find cool puzzles online and then try to solve them, during the dinner table. And a couple weeks ago, we stumbled upon this puzzle titled "Finding the Injection for Anesthesia." And after a few minutes of thinking about it, my dad basically said that it's impossible, and I was like, "There's no way it's impossible." And I was thinking about it for a while too, and I was like, "Wow, it might really be impossible." And then we checked the solution, and then oh my goodness, it took us like a week to actually understand what really happened. So I thought it would be a perfect opportunity to make a video on it. But it's a really simple puzzle. Don't be scared by all the text. It has really simple rules, and it really on first hand it looks like it's unsolvable, and then the actual solution is crazy. Like it makes. I mean, it's really smart and it makes a lot of sense. So I'll talk about it today. Basically, what are the rules of the game? We have 243 injections, and exactly one of them is the anesthetic, which means if you get the anesthetic, it's something that makes you fall asleep. And basically, what happens is and we have 5 rats. We have 5 test rats, which are gonna help us. Basically, our goal will be to identify the anesthetic in 48 hours. And the rules are: if a rat receives the anesthetic, it will faint, but it won't faint immediately. It will faint sometime in 24 hours. So it's either gonna faint, as soon as it gets it, or it's gonna faint in 5 hours, or in the worst case, it's gonna take 24 hours for it to faint. And then once the rat faints, it can no longer be used. So it's gonna be asleep. It won't die, I swear. It's just gonna be asleep. A rat can also get multiple injections. So a rat can get all 243 injections. And then obviously, sometime in the 24 hours, it's gonna faint because one of them was the anesthetic, and the other 242 are gonna do nothing. And injections can be also used multiple times. We can give all 5 rats, injection one. It doesn't run out. And basically, I mean, it seems completely impossible at first because again, we have only 5 rats, one, two, three, four, five, and again, if we give, let's say we just give, we first of all give, this is rat one, two, three, four, five, and then let's say we give it, injection one. We put the first injection into the first mice, the second injection to the second one, then third, fourth, and fifth. So we give them 5 injections, and now we have to wait. We have to wait 24 hours, maybe. Because if we put another injection into mouse one after 2 minutes and it faints after 5 minutes, we don't know. Was it this injection that made it faint? Was it this one? We don't know. So we have to wait 24 hours. And then at the end we're gonna in case rat four faints, then we know it's this injection. But realistically none of them are going to faint. So then and then we only have 24 hours, so we can give 5 more injections. There's no way we can test all 243 injections in 48 hours, right? How is that possible? Well, I mean, of course, turns out that it is possible, and today we're going to see exactly how it is possible. First of all, we have to talk about strategy. Why is this important? Injections can be used multiple times. Well, I'm gonna go over some different strategies. First of all, I mention why they don't work, so you can see how clean the actual strategy is. Well, basically, if we don't reuse any, if we don't reuse any injections, we have 5 rats. One, two, three, four, five. I know that they're just circles. Imagine the rats. And let's say we have our 10 injections. I'm gonna draw them here. So we have injection one, two, three, four, five. 6, 7, 8, 9, 10. These are just they're just lines. Imagine they're injections like the one I drew before. Let's say on day one we give injection one to mouse one. Then we give injection two to mouse two. We get injection three to mouse three. Injection four to mouse four. Five to mouse five. And then we wait 24 hours. So wait 24 hours, and that's the end of day one. And then at day two we give injection six to the first mouse. Injection seven to the second mouse. So bang, and we give the last injection to mouse five. And then again we wait 24 hours. So now we tested 10 injections, and if mouse 1 falls asleep on the second day, then we know that it was this injection. If mouse 2 falls asleep on the first day, then we know it was this injection over here. With this strategy of using an injection only once, and we have 5 mice and we only have 2 days, we only have 2 cycles, we can at most, we can test at most 10 injections. This is an absolutely terrible strategy. We can't test more than 10 injections that way. This is we have 10 bits of information. This is all we can use. It's a pretty terrible strategy. That's why we have to use injections multiple times. We already have 243 of them, and then we have to use them multiple times. It sounds unbelievable, but we do have better strategies already. If we have 243 injections and we have 5 mice, again 1, 2, 3, 4, 5. Well, okay, let's maybe try to split the injections into 5. Because 243 divided by 5, that's about 50. Let's say we have 4 groups of 50 and 1 group of 43. And we're gonna say that each mouse, so mouse 1, 2, 3, 4, and 5. On day one, each mouse is gonna get a batch of 50 injections. So we're gonna split. We have 243, and we're gonna split it into 5 batches. Here it's gonna be 50 injections. Another batch, another batch, another batch, another batch. Mouse one is gonna get this batch of 50 injections, so we'll give it injection 1, 2, 3, 4, 5 up to 50. Mouse two is gonna get injection 51, 52, 53 up to 100. So each mouse is gonna get its own batch of injections, and then we're gonna wait 24 hours. So we're gonna wait 24 hours, and then one of the in one of these batches, there's gonna be the special injection. These batches have a bunch of injections. One of them is gonna have the special injection, which is the anesthetic. So the mouse, let's say that we gave this batch to mouse two. That means after 24 hours, this mouse is going to faint. All these mouses are gonna be fine, but mouse two is gonna faint. So we know that the injection is somewhere in those 50 guys. So now we can expand those. So we have 50 injections now, and one of them we know is the anesthetic, and we have 4 mice left again because mouse two fell asleep. So now we have these mice left. So now we have mouse we have this many mice left. We have mouse 1, 3, 4, and 5. 2 is asleep, and we have this batch of 50. And now we divide that by 4, and now we're gonna have that's about 13. So now each mouse is going to get about 13 injections. So we're gonna have batches of we're gonna have 4 batches of 13. Each mouse gets its own batch. And now again we're gonna wait 24 hours. Wait 24 hours. Exactly one mouse is gonna fall asleep. Let's say the special injection was in this one over here, which mouse one got. Mouse one is gonna fall asleep in those 24 hours. So we know the injection has to be in one of those. We know the anesthetic has to be in one of those 13, in this batch. We got it down to 13, which is, a better strategy already. But actually, this strategy is completely terrible too. Because how many mice could we actually test this way, if we actually wanted to definitively find an injection? Well, it turns out it's only 20, which is actually terrible. Why? Because if we look at it from an information analysis point of view, on the first day, on day 1, we have exactly 5 outcomes. Because we have 5 mouse, we have 5 mice. We have mouse 1, mouse 2, mouse 3, mouse 4, mouse 5, and after day 1, exactly one of them is gonna faint. So one of them is gonna faint. That's exactly 5 outcomes. Either mouse 1 faints, either mouse 2 faints, and so on. One of them is gonna faint. And on day 2, we only have 4 outcomes. On day 2, we have 1, 2, 3, 4 mice left. And then either, this one's going to fall asleep, either this one's going to fall asleep, either this one or this one. So on day 1, we have 5 outcomes. On day 2, we have 4 outcomes. That's a total of 20 outcomes, Either, let's say mouse 4 falls asleep on the first day, and then mouse, so then mouse 4 won't be in the game anymore, and then mouse 1 falls asleep on the second day, Or either mouse 5 falls asleep on the first day, and mouse 1 falls asleep on the second day. So, there's 20 possible ways that, we can arrange this. That's 20 outcomes, so we can test at most 20 injections, which again is terrible. How are we ever going to get to 243? Well, we have to extract the most amount of information that we possibly can from this system. And turns out this system of 5 mice, 5 mice and 2 days actually has way more information that we think. Basically, we have to look at the mice in terms of states. So we have 3 states that each mouse could be in. 3 states at the end of the 48 hours. After the 48 hours, a mouse can either be awake. A mouse can either be awake, so it never fell asleep. That's gonna be state 1. Either it fainted or fell asleep. Either it fainted in day 1. Fainted on day 1, or if it doesn't faint on day 1, the other possible state is that it fainted on day 2. Oh my goodness, fainted on day 2. There are 3 possible states for a mouse after 48 hours. So 3 states after 48 hours. Either it's not gonna faint, it's gonna faint on day 1, or it's gonna faint on day 2. And we have 5 mice. We have 1, 2, 3, 4, 5. There's 3 possible things. If we name the state awake 0. So if a mouse has a number 0, that means it never fell asleep. Then this state can be named 1, and this state can be named 2. Well, then here for the first mice, it can either have a 0, a 1, or a 2. So there's 3 possible combinations here. And again, there's 3 possible combinations here. There's 3 times 3 times 3 times 3 times 3 times 3. There's 3 to the power 5 possible combinations, which is exactly 243. Oh my goodness, that's why I said 243 injections. We could also say 240 injections, but at most, our puzzle setup has enough information to distinguish 243 possible states. Again, this is going to be a 5-digit code. I can remove the 0. This over here will be a 5-digit code. We can have, we have numbers 0, 1, and 2 for all these 3 possible states. And, each single mouse can have, a specific number. Let's say a mouse can have, 0, 1, 2, 1, 1. This is one possibility. That means that mouse 1 never fainted. This is mouse 1, this is mouse 2, and so on. Mouse 1 never fainted, mouse 2 fainted on day 1, mouse 3 fainted on day 2, and mouse 4 and 5 both fainted on day 1. This is one possible combination. Then we can have another possible combination. We can have a combination, of 1 1 1 1 0. We can have 1 1 2 2 2. There's 243 possible combinations of this 5-digit code, and the whole idea is that we're gonna give each injection a specific code. We're gonna assign, we're gonna assign. Oh my, well, this is. I'm spelling is just not going today. It's never going. We're gonna assign to this ID, this 5-digit ID to each injection. So each injection will have a specific ID. Let's say injection 1 is going to have an ID of 01121, and injection 2 will have a different ID, and that just means that if injection 1 has this ID, that means on days and this ID corresponds to the different mouses. This first digit corresponds to mouse 1, second digit corresponds to mouse 2, this corresponds to mouse 3, to mouse 4, and to mouse 5. So this means that on the first day, mouse 1, mouse 1 will never get injection 1. Mouse 2 and mouse 3 and mouse 5 are both going to get injection 1 on the first day, and mouse 4 is going to get injection 1 on the second day. This is what this ID means. And again, each injection will have its own ID. This is going to make a lot more sense when I do a little small example. So let's say we have injection 1. Let's say we also have injection 2, which has ID 1 1 1 2 1, which means mouse 1 2 3 and 5 are all going to get injection 2 on the first day, and they're going to get injection, and mouse 4 over here, on the fourth digit, is going to get injection 2 on the second day. This is all that means. Each injection has its own digit code. The first digit corresponds to mouse 1, and then mouse 2, mouse 3, and so on. So let's say we have injection 3, which is going to have a digit 0 1 1 1 2. I'll just do this for 5 injections, so you're going to see the gist of it. Injection 4 is going to have 1 1 2 1 0, and let's say injection 5 is going to have code 1 1 0 1 2. Again, there's 243 possible combinations, so we can have 243 injections, which each have their own unique code. And at the end, only one of these codes will be correct. But for now, I can just do an example with 5 codes, just because it's the same thing. You're gonna see how it works. Now, the special thing is, most of these injections don't do anything. Only one injection. Let's say injection 4 is the one that's actually the anesthetic. All the other injections, we're gonna be putting them into the mice, but nothing's gonna happen. So let's just do our setup right now and see how this works so beautifully. So we have mouse 1. So here we have day 1. Day 1 is when our challenge starts. The first 24 hours, and we're gonna see what happens to each mouse. So I'm pretty sure I said rat and I would switch to mouse, but it really doesn't matter. So mouse 1, on day 1, it got what? It got mouse 1, is here. Mouse 1 is going to be on the first, the first index. So mouse 1 did not get injection 1. It's never going to get injection 1. Mouse 1 got injection 2. It got injection 2 over here. It never got injection 3. It got injection 4, and it got injection 5. So it got, I can just say, I can write it here actually. Mouse 1 got injection 2. It got injection 4, and it got oh my god, how am I spelling this? And it got injection it got injection 5. This is what mouse 1 got on day 1. Mouse 2, well, what did mouse 2 get? Mouse 2 again is the second index over here. Mouse 2 got also injection 1. It got injection 1. It got injection 2. And in fact, it got injection 3, it got injection 4, and it got injection 5. Mouse 2 got every single injection. So it got injection 2, injection 3, injection 4, and injection 5 on the first day. Mouse 2 got all these injections. Mouse 3, well, let's see what happened to mouse 3. So you can see how, this works so beautifully. It's such a intrinsic system. Let's see what mouse 3 got. Mouse 3 got injection 1, it got injection 2, it got injection 3. It did not get injection 4. It's going to get injection 4 on the second day, and it's never going to get injection 5. So mouse 3 got injection 1, it got injection 2, and it got injection 3. Mouse 4 got, let's see what mouse 4 got. Mouse 4 on day 1, well, it's going to get injection 2 later. It's going to get injection 2 later. It's going to get injection 1 and 2 later. It got injection 3, it got injection 4, and it got injection 5. So mouse 4 got injection 3, injection 4, and injection 5. And now the final mouse, I don't know if this is boring, but this is just to really clearly see what exactly happens. Mouse 5 got injection 1 on the first day, it got injection 2 on the first day, and that's it. So mouse 5 just got injection 1 and it got injection 2. Bang. This is absolutely beautiful, okay? And now we can see what's gonna happen at the end of day 1. Well, we know that injection 4 is the actual anesthetic. Injection 4 is the one which actually puts the mouse to sleep. All the other ones don't do anything. So after day 1, mouse 1 got injection 4. It also got injection 2 and injection 5. So after day 1, mouse 1 is going to be asleep. Because, again, it got injection 4. 2 and 5 won't do anything, but it still got injection 4. Mouse 2 also got injection 4. So at the end of day 1, it's going to be asleep. Mouse 3, it never got injection 4. Injection 1, 2, and 3, are not anything. So it's going to be awake. Mouse 4 also got injection 4. So it's going to be asleep. And mouse 5 never got injection 4. It only got injection 1 and 2. So it's going to be awake. So now immediately after day 1, just by looking at what each injection does, looking at the code of each injection, we know that injection 1, injection 2, and injection 3 cannot be the anesthetic. Because again, mouse 5 got injection 1 and 2 and it's awake. And mouse 3 got injection 1, 2, and 3 and it's also awake. So we know that injection 1, injection 2, and injection 3, they are not the anesthetic. How do you spell anesthetic? It's actually really hard. They are not the anesthetic. The only possible anesthetic that we can have is injection 4 and injection 5. Because again, mouse 1 is asleep and it got both 4 and 5. Again, mouse 2 is asleep and it got both 4 and 5. And mouse 4 is asleep and it got both 4 and 5. So injection 4, injection 5 are the possibilities. And we see that also, the only mouse we have left is mouse 3 and mouse 5. So on day 2, we only have 2 possible injections left, and we also only have mouse 3 left, and we have mouse 5 left. All the other mice are asleep. Mouse 1, 2, and 5 are asleep. So we only have this mice left, and we have this mice left. And now we can move on to the tests of day 2. Well, on day 2, let's see what mouse 3 gets. Mouse 3 on the second day, again, it got injection 1, injection 2, and injection 3 on the first day already. So mouse 3 on the second day only gets injection 4. We can see, injection 4 has a 2 over here. So mouse 3 gets injection 4 on the second day, and that's it. And mouse 5 on the second day, it gets injection 3 and it gets injection 5. But again, we know that injection 3 is not it. We already figured out that injection 3 is not the anesthetic. We can give injection 3 to mouse 5 on day 2, but nothing's gonna happen. Nothing's gonna change. So we can either give it or we don't. It doesn't matter. But it gets injection 2 and it gets injection 5. Injection 5 is the one we're actually interested in. But we can say that mouse 5, it gets injection 3 and it gets injection 5. And again, we already know that injection 3 is not the anesthetic, so we can also not give it to the mouse. And now again, we wait 24 hours until the end of the day, and we're going to see that mouse 3 at the end of this day is going to be asleep and mouse 5 is going to be awake, because again, injection 4 is the anesthetic. So now we can see that, when injection 5 can be the anesthetic, it has to be injection 4. This is the one that wins. Oh my goodness. It's absolutely beautiful. And again, realistically, if we have 243 injections, we wouldn't do this specific way where we cross out, one by one injection, at the end of each day. We would just do, we would give these injections as they're labeled, to mice in either never or on the first day or on the second day. And then we just, write down the ID which we get. So, at the end, we have, so what happened? We have 1, 2, I'll write this a bit smaller. But we have, mouse 1, mouse 2, mouse 3, mouse 4, and mouse 5. And now we can see what happened. What happened to mouse 1? Mouse 1, it fell asleep on the first day. So mouse 1, it fell asleep on the first day. So it has a 1 over here. Mouse 2 also fell asleep on the first day. So it's going to have a 1 over here. What happened to mouse 3? I forgot. Mouse 3 stayed awake on the first day. And mouse 3 then, it stayed awake on the first day, but then on the second day, it fell asleep. So mouse 3 fell asleep on the second day. So it's going to have a 2 over here. Mouse 4 stayed awake both days. Mouse 4 fell asleep on the first day. We have day 1. Mouse 4 fell asleep. So mouse 4 fell asleep on the first day. So it's also going to have a 1. And then mouse 5, it stayed awake both days. So mouse 5, it was awake after day 1. And then on day 2, it was also awake. So we never got the anesthetic. So we just always stayed awake. So we're going to put a 0 over here. Again, these are the states. Stayed awake always, fell asleep on the first day, and then the number 2 corresponds to fell asleep on the second day. Well, which injection has this combination? Only one of the 243 injections will have this combination. Because, if at the end of the day, if at the end of the 2 days, these 5 mice have these states, that means, they had to get an injection, which, only one injection is gonna work for this, and it's gonna be the injection that got put into mouse 1, 2, and 4 on the first day. It got put into mouse 3 on the second day, and it never got put into mouse 5. Well, which injection has 11210? Well, let's see. Each injection is labeled. Oh, injection 4 is 11210. We know that injection 4 has to be the one. Again, it's so clean. We're gonna have 243 injections, each with their own code. We're gonna, give the mouse, each injection at the specific, either day 1 or day 2 or just never. And at the end, we're gonna write down what happens to all the 5 mice. So we're gonna have in our label when they fell asleep, either on day 1, either on day 2, or never. We're gonna write down the code for what happened at the end to all the 5 mice, and then we're gonna see exactly which injection must have caused that. And that is how we solve the puzzle. Absolutely beautifully, very clean. Thank you for watching. I think it's pretty cool, and hopefully my dad is gonna believe me now when I show him this video that it is actually solvable.